Now, the reason I included question 7 is it's the type of question that really confuses people a lot of the time. So what they're saying is that we have a quadratic, a parabola means a quadratic, and its form is like this, y equals ax squared plus c. So what they're saying is that there's no x term. That it's going to look something like, 3x squared minus 2, for example. So it might look something like this. This is just an example. And if we found out that it looked like this, then a would be equal to 3 and c would be equal to -2. So we need to answer this question, and we start by writing down our formula, y equals ax squared plus c. And they told us two other things, that it passes through 2 points, -1, 4 and 0, 8. Now remember, points give us values for matching x, y pairs. So what this tells me is that if I sub in x equals -1, I can also sub in y equals 4 into this formula here. So I get a by -1 squared plus c is equal to 4. And when I tidy that up, -1 squared is just 1, so a plus c is equal to 4. I've got an equation with two unknowns in it. I do the same thing with the other point. So when I sub in x equals 0, the y value will be equal to 8. And so I've got a by 0 squared plus c is equal to 8. And of course this goes away, so c is just equal to 8. And that's the second piece of information I have, and they made it really easy for us. We can now replace the c value over here. We didn't even have to solve simultaneous equations. So a is equal to 4 take 8, which is -4. And that's the answer to the question. They asked us to find the values of c and a. They didn't ask us to do this, but I'm going to do it anyway. It means that our function was -4x squared plus 8. It's always useful to bring it back to where the question came from. So that was question 7. Just to remember, if they give you points on a function, you can sub in the x and the y values to make an equation. Okay, let's take a look at the next question, question 8. We're asked to determine the equation of each of the following parabolas. So we're asked to find the quadratic equation here, or the f of x, or set it equal to 1 if you want to. What do we have? We have 2 points. We have this point and we have another point here. And what I like to do with these ones is just use the roots and see if the other point makes sense, because it's quicker than coming up with simultaneous equations. So for question 8, part 1, I have the points -3, 9, and I also have the point, we can see it goes through the origin, I have the point 0, 0, which means I have, maybe it's easier to understand if I do it the long way. I was going to take a shortcut, but I think I'm not going to. We know that every quadratic is in the form ax squared plus bx plus c equal to 0, well, f of x equal to it actually. F of x equal to that. The equal to 0 is when we're finding the roots. So that's the format, or y equals that. So when I put in x equals -3, I'm going to put in y equals 9. But before I do that, I'm going to use my 0, 0. Why am I using the 0, 0 first? Because it's going to make things really easy for me. When I put in x equals 0, I get 0 plus 0 plus c equals 0. So that means c is equal to 0, and my equation is actually in the form y equals ax squared plus bx, like that. Now, do I have quite enough information? Well, when I sub in, let's try it. We sub in x equals -3 and y equals 9, and we get a by a minus 3 squared plus b by minus 3 equals 9. So what we have there is 9a minus 3b is equal to 9. That's my first piece of information. Now I'm stuck. How do I find the other piece of information? We use symmetry. If this point is on the graph, then this point, the symmetrical point of 3, 9, must also be on the graph. So that means that I have a third point. I have the point 3, 9 on the graph as well. So when x is equal to 3, y is equal to 9. And subbing those in, I get a by a plus 3 squared plus b by a plus 3 is also equal to 9. And so 9a plus 3b is equal to 9. And what you'll notice is that these two equations are really near to each other. And what we find out is that we can add them together. So we can just add them together without changing any signs or anything like that. 9a plus 9a is 18a. The b's cancel. 18a is equal to 18, which means a is equal to 1. And once I have my value for a, I can replace it up here. So 9 by 1 minus 3b is equal to 9. Minus 3b is equal to 0, and b is equal to 0. So I have my three values now. A is 1, b is 0, c is 0, and so f of x is equal to ax squared, x squared, plus bx, 0, plus c, 0. Was there any other way we could have done that? Yes, absolutely, just using the roots. And have a think about a shortcut you might have been able to take from that, knowing that we had equal roots at the point 0, 0. Was there a shortcut we could have done there? Okay, let's look at part 2. We start to go a little bit quicker now as well. Oh, sorry. Is that okay? Okay. So for part 2, again we have 3 points. But what I like to do is use my y-intercept will always be my constant, and my roots are the opposite of my factors. Part 2, what I would do is I'd start by saying that my roots that I worked out there, x equals 1 gives me a factor of x minus 1, and x equals 3 gives me a factor of x minus 3. And when I multiply those out, I get x squared minus 3x minus 1x plus 3, and that's x squared minus 4x plus 3. So there's my f of x. Does it make sense? Well, my y-intercept is at 3. Sorry, not 0. My y-intercept is at 3, as I expected, and my constant term is equal to 3. So I'm happy that that makes sense. So that was much quicker. The next one is upside down, but again I'm going to use my roots. So my roots are at x equals minus 3 and at x equals a plus 1. And I'm going to do this just like I did before, changing the signs. X equals minus 3 gives me a factor of x plus 3. X equals plus 1 gives me a factor of x minus 1. Multiply out my brackets. X squared plus 3x minus 1x minus 3. Simplify x squared plus 2x minus 3. But that won't give me an N-shaped graph. Okay? So I just need to change the signs. F of x equal to minus x squared minus 2x plus 3. Okay, we can verify this by subbing in x equals minus 1. And we get minus a minus 1 squared minus 2 by minus 1 plus 3. That gives us minus 1 plus 2 plus 3 Why isn't that working out? I think there might be a mistake in the question, or else I've made a mistake somewhere in my calculations. That gives me a plus 4. That's telling me that the point minus 1, 4 is on my function. I think there's a mistake in the question, but I'm just going to double check here. My roots were at minus 3 and plus 1. Multiply out. I think that this point, and you might verify it when you're doing your own homework, this point should have been minus 1, 4. Because when I sub in the x equals minus 1, I should get that point. Okay, I'm happy enough with this method though, unless I've made a mistake that I'm not spotting here today. Okay, so I'm going to stop the video there and then we'll do questions 9 and 10 in a separate video.